So today we're going to start looking at the data we have collected, and regardless if you find the data online in raw form or if you have produced it by collecting it yourself and writing it down, we're going to start building together a set of tools to be able to do something with this data in a bit more comfortable setting. So the idea behind this is that we're going to start with some raw data, and those are going to be individual points or some repeated events that have a certain level of frequency. So data with frequency. And in either one of those cases, if you have been collecting the data for a while, the number of those points is going to get extremely large. Now, one could take the individual data points, and if they repeat, create the data with frequencies. One could assign a timeline to it. So the way we start talking about this or start collecting it is one part of the exercise. Second one is we're going to take this data point, the set of data points, and we're going to create a table that allows us to look through the data and do some very basic units. So this is the initial table. All right. Having an initial table, one could realize that the number of rows or columns in that table is going to be very large. And the bigger it is, the more data you have, the easier it is to see patterns. Except when it gets too big. If we have to scroll through a spreadsheet for thousands of lines or thousands of columns, it gets very difficult to figure out what we can do with it, which makes this somewhat unusable. The one way to solve this is if we can use this idea of data with frequencies and create a class frequency distribution. Table. What it is a table which has some classes which lists some ranges, right? And the number of frequencies we have for each class. So if we have collected the ages of students at a university, they will range from, say, 17 to 71, but that means a lot of points, right? Each one of those points will have some corresponding frequency, and so on and so forth. But we could group them up into little packets, say 17 to 22, right? Then 23 to 28, then 29 to 34, and so on and so forth, and assign some frequency to those. This way, the number of entries here is going to be much smaller, because that will be 35, 41, 47, 53, 59, 65, 71 to 40, 46, 52, 58, 64, 70, and 76. Right? and we have some corresponding frequencies which we can add up here. So what I'm going to do today is I'm going to try to show you an example of how I build this from the data I have been collecting for the past month. So let's get to the spreadsheet. I'm doing it in Google Docs just in case the data you have, the system you have available to you, is not a PC or a Mac with the Microsoft Office installed. So I'm going to do this in Google Docs, since Google Docs are available to you through the hawaii.edu account. So first things first, my data, the one I have been collecting, has the following sets of columns. It has a date. Maybe we should move it here. It has some date. It has a weight. It has a column called sleep, and it has a column called steps. Now I'm going to start filling this out. So the first measurement was done on 1/6/2019. Second one was measured on 1/7/2019. And if this is smart, it's going to start adding things up for me. Perfect. And I'm going to just stretch it. February, March. Oh, perfect. So we have all the dates put together. Right. So that's step one. Second one is weight, and I'm going to start plugging it in here. Right. For you, the video is going to get speed up because you don't need to sit with me while I enter this whole thing. So put some music on and let's rock. Right, so after we have entered the data, I'm going to put a title here that's PUBA 310 data sheet. Right, so we have this data, and now we can notice that in a couple places we're missing pieces of data. Either the data wasn't available, got corrupted, we didn't record it. In this case, because the data I'm looking at is an account for weight with a check every day, I could have those 3 spots right here filled up with numbers which I'm going to approximate. And the way I'm going to approximate this, and I'm going to take an average of the one before and then one after. So we go equal, open parentheses, the data before, the day after, divide by 2. The day after divided by 2. And the same thing is going to happen here. Equal, open parentheses, the day before, plus the day after, close parentheses, divide by 2. And then the last one, the day before, plus the day after. We'll have to put parentheses around it. Divide by 2. Alright, so now we have a full set of data. So there's a couple of things we can do with this data. First thing we can do is we can take a look at the average. So average, open parentheses, we're going to highlight this whole column, close parentheses, and we have the average that shows up for this whole period. All right, so this is average. We could type in the same thing, equals average, and do the whole thing, or we can just drag it across. And as you see, it changes from the C column to the D column. And this tells me the average sleep and the average number of steps. Okay, easy. We could find standard deviation. Insert function database. Oh, here it is. Statistical average standard deviation should probably be here. This is important. This formula is for population, so if we drag it as across, we can get the remaining. But if we go and look at the sample standard deviation again, why would we do that? Is because what you're collecting might not be a population. Then we're going to go standard deviation dot sample, and we expect this number to be slightly bigger than the previous one. And here it is, it's slightly bigger. Okay, so we have created the standard deviations. Okay, what else? We could find the minimum, the median, and the maximum. And again, equals minimum of this. We could find the maximum, the median, and the max. And again, the structs overcrux. Cool. So I think this is a nice start to talk about this, right? If we are talking about describing data, that's one way we can look at it. The problem is, if I'm trying to look at this data, there's a lot of points here, right? And as much as I know the average and the median and the standard deviation, this set of data becomes somewhat troublesome, because we really want to avoid large tables. So we want to create this kind of class system for our table. The way we would do that is we would take a look at, in the script I provided you here, steps for creating frequency distribution. Now, how many classes are you picking up? There are different philosophies. If you take as too small number of classes, then you lose resolution, because what you're going to get out of all this data, you're going to get couple big blocks, and that doesn't tell you anything. So this is too small number of classes. On the other hand, if you have too many classes, you're not going to get much more resolution than this. So you want to grab somewhat of a sweet middle. Now, the way we can look at it is we can look at right here. That the number of classes could be taken as a square root of the number of points you have. Now, again, this is an estimate, it's a rule of thumb, so we have to account for that. So if we take a look at our classes, well, how many points we have? There's a couple ways to do it. We could number the points 1, 2, and we can, drag this. Well, I got too excited. Drag this across, and we realize that we have 75 entries, right? So data entry. We could also just count them. So counting entries equals count close, and here it is, right? So counting entries. What is counting entries? Well, counting entries, and if you take a look at it, it works for every column, right? Oh, sorry, go back. And if you're counting entries, well, what are you counting really? Well, you're counting the n, right? The n, so the sample size or your population size. So we counted that, and we got 75. Cool. So far, all the calculations are done by the spreadsheet, so we're in good shape. Right. So what can we do more with it? Well, now that we have a number of entries, we could consider a class width. If we remember that, class width is defined as the maximum value minus the minimum value divided by number of classes. So if we go back to our thing, we're going to go class width, and that equals to max maximum minus minimum, right, divided by number of classes. Well, how do we get number of classes? Well, number of classes, we looked at number of classes as a number that equals to, so number of classes, we're going to estimate it to be a square root of n. So what is the square root of n? Well, equals square root of this. So we're expecting to have 9 classes. Why do we round this? So this equals to round up of that. So why do we expect to get 9 rounding up? Because if we round down, the last classes are going to end up being too small. All right, so we have the number of classes. Okay, so this is all great. We did all those little setups here, and again, I will be sharing the spreadsheet with you, so you will be able to take a look at it. All of this is great. All of this is fantastic. We collected data. We have this data. We have done all this fancy, calculating and adding and multiplying. Except one big issue. And the big issue we currently have with this data is we don't know what we are calculating. So if we go back to our drawing board, the question remains, the question remains, what, why, and how? Right? Your research question, the idea of what are you going to check? And the way we phrase this question is going to affect the way we measure things. So we could, well, what do we have? I collected data for the weight, the sleep in hours, and the number of steps whenever I felt like putting my smartwatch on. So weight in pounds. Yes. So questions. Does the number of hours of sleep affect weight gain or lost? How's that for research question, right? If I sleep a lot, I should be losing weight. So the question is, what is the dependent versus the independent variable? Well, the dependent variable is weight, right? This is what I'm interested in. What are the independent variables? Well, sleep and steps, right? Could be that, you know, we could have phrased this: does the weight of a body before you go to sleep affect the number of hours of sleep you get? And in this case, we would have to switch sleep and this. So those two are affecting this one. So when we are creating our frequency distribution table, we can create one for each one of those things and take a look at what the pattern is, what the distribution is. So what I'm going to do is I'm going to create a frequency distribution for each one of those, just so we can take a look at what happens in each case. Maybe there's a pattern. So let's go back to the web. So I'm going to add a new sheet, and I'm going to call it weight. Then I'm going to have a sheet called sleep, and finally a sheet called steps, remaining the first one as raw. So for weight, again, in all cases we're going to be looking at 9 classes. So number of classes is 9. That's set, and then we're going to look at the maximum for each minus the minimum divided by 9, and we're going to get the class width. Right. So let's take a look. Yep. So class width. I'm going to put those over here. So class width for the first one is equal to maximum, which is maximum, minus the minimum divided by number of classes. Bam. So class width is 1.1. We're looking at F, and we're looking at F. Now, classes can be fractions, especially because I have included fractions here, so classes can be fractions. Right. So now we have our three classes. Cool. So we have our class widths. So for weight, we're going to create the setup. So we have number of classes. We have the minimum, the maximum. What else we had here? We had the class width. Okay, so number of classes. Well, that equals to this. That's our number of classes. And that's how we can transfer a piece of data from one sheet to the other. Minimum is, minimum equals to this. Maximum equals to that. And class width equals to this. Now, why am I doing this way? I'm doing it this way for two reasons. One is because this is the more complicated part, so I want to show you how to do the transfer of the cell values even if you have never used Excel. If you want to actually type it in 2007.8, sorry, 207.8, 217.6 and 1.1, that's fine as well. It's up to you. This is how you can manipulate the data regardless of the size, because the calculational speed for the spreadsheet is much higher than you with your calculator. Alright, so now we're going to build the setup. So if we take a look at the script, what we want to do is we want to start with the smallest number and then add the class width to it. Now again, here I'm rounding it to a whole number because we're talking about years, and 0.14 years doesn't make sense, right? 0.14 years doesn't make sense. So in our case, it does. So what we have here is, right, now that we have created the initial class widths, let's take a look at the actual setup. So what I have here is the minimum, the maximum class. The problem is this is if we take a look at closely at it, this has a lot more decimal places in some cases than we would like. So we want to make sure that this is representing of what we want. So what we're going to do is we're going to put a function called value, which what it does, it picks up the value that is displayed in the cell on the previous spreadsheet, rather than being susceptible to some variation due to decimal places we don't see. So I'm going to put value for each one of those. Again, if you look at closely, this has extra decimal places, but the moment we type in here, let's actually keep the decimal places. So decimal places, but if the moment we type in here value, it turns around to be a single decimal place. Right. So now we're going to build the table, and our table will look something like this. There's going to be 9 classes, as we established. We're going to have a lower class limit, upper class limit, some lower boundary and upper boundary values. So what is the lower class limit? Lower class limit, the first one is the minimum. So this one equals to the minimum. How big is the second lower class limit? Well, class limits define the distance between two lower class limits or two upper class limits. So what this is equal is to the previous lower class limit plus the class width. Now, because we're going to keep on using class width, we're going to put press S4 and put two dollar signs. These dollar signs will make sure that while I drag this into all the remaining cells, the previous term, the first term, is going to attach to the one above, where the second term is always going to be drawing from this cell. Again, that's very easy to do by hand. So what is upper class limit? Upper class limit is going to be whatever we have here minus 0.1, because 0.1 is the smallest distance we can have. So this is equal to this minus 0.01. And again, how big is the next one? Well, the next, sorry, 0.01. How big is the next one? The next one is equal to this one plus the class width. And so we have the next one. Now, if we didn't done everything correctly, this number is going to be equal or greater than the maximum value we have here. Lower boundary and upper boundary are numbers that divide the classes apart. So what this means that if we have a class from 207.8 to 208.8, the next class starts at 208.9, and we have this little gap here. The difference between a histogram and a bar chart is that those bars supposed to touch. So what we do is we extend them just a tiny bit, giving the illusion that we cover all the data. There is no piece of data that is smaller than 8.9 and bigger than 8.8 because we measured weights within plus or minus 1. So it's either on one side or the other. But this gap will be there. So to remove the gap, we're just going to put a little line here. And this line is going to split the distance between this side and this side in half. Well, the distance between this and this is 0.1. So how big is the distance each one of those? It's 0.05. So what we are going to do is for lower and upper class boundaries, we're just going to add and subtract 0.5. So let's take a look at this. So what's the lower class limit? Well, the one before that. So that equals to this minus 0.05. What's the upper one? Well, that equals to this plus 0.05. See, this number is going to be slightly greater than this and slightly below this, and exactly in half between the two. So we can just stretch this across, and this is how we create class boundaries. Now that we have created a table with both the lower and upper class limits, we created two columns with lower and upper class boundaries. The next step would be to produce a column called the class frequencies that count the frequency of data values falling into each one of the classes that we have established. The way we're going to set that up took a little bit of research, and there is a way to do it by just simply counting the data values that fit between 207.8 and 208.8. However, we can use a formula for it. So what we're looking for is to sum all the counts that fall into a specific category. We want things that are greater or equal than the lowest class boundary. So for that we need the range that we're going to be looking at. Oops, too far. Okay, got this. So this is the raw data. So we're looking at a range that is all the weights we talked about it, with the condition that they're greater or equal than what? Well, then the lower class boundary. Again, what we are doing is we are setting up a function saying sum the count of all the raw data that are greater than lower class boundary, and let's copy this range again, and all the data from that range that is smaller or equal than the upper class boundary. And the formula for that is the range, comma, quotation mark, the symbol you're looking for, close quotation mark, and this. There might be another way to do it. Now, I am going to make the range as absolute, so when I drag it around, the range doesn't change this. And what we get is all the frequencies. Now, one way to check up is if we sum all the frequencies, we should get the size of the sample, which is 75. So if we sum all of the frequencies, we should get 75. We get 75. Great. From here, we can look at for relative frequencies, which is the percentage of data points falling into each class, and relative frequencies are defined as a frequency divided by sum of all the frequencies. So in the case of first class, that's 2 divided by the sum of all the frequencies, which is 75. Again, we make the 75 absolute by pressing F4, just so it doesn't changes when we drag it down. Now there's a lot of decimal places, so we're going to reduce the number of decimal places to 2 decimal places, which should be more than enough. Again, this is for just show and tell reasons. And so we have all the frequencies. Now we know that all the frequencies all the relative frequencies should add up to 100%. So all the points have been set up. We checked it with frequencies, we can check it again. So if we do sum of all the relative frequencies, we should get 100%. Perfect. Which means we did a good job setting up the equations. All right, so we have. So now that we have this tape set, it's curious what else can we do, because the setup is just half of the story. We could try to calculate the expected value for this frequency distribution. Although, if we look at the script, the mean of a frequency distribution is defined as the sum of x times f. Well, what is x? X is defined as a value we use to associate with each class. Since classes are ranges, in the first class is from 207.8 to 208.8. That's a range. So what we're looking for is a point that would define that class. In our case, the point that is define the class, we will use a midpoint to do it. Again, the classes are we don't know how the points are defined in each class, so what we are trying to do is we're trying to find a one point that we can associate with the whole class. Now this is very beneficial if we are working with either with aggregate data we already created, or if we want to double check our aggregate. So the midpoint is simply defined as the average between the lower class limit and the upper class limit. So we go equal average, we pick the two numbers, and here it is. So this is a midpoint we are looking at. And again, it's worth noting that each midpoint is away from the next midpoint by class width. So we have a column defined as our x. So we're going to create another column. We're going to create another column that is called x times f. Right? So again, value that we use to associate with the given class times the frequency of data values in that class. So that equals to the midpoint times the frequency. And again, we can drag this down. Kaboom. So now we need the sum of x times f. So the sum of x times f. So value times frequency. Let's put some spaces here so it looks better. That equals to sum of this range. Enter. This number might appear to be big and weird looking for this table, but remember this number is sum of all the frequencies times the value. So this number by itself doesn't have a meaning that is very easy to associate. What this number means is the sum of all the weights for this. So what we did next is we took this average and we divided by the sample size. And what we realized very quickly that the number we got from the mean for the frequency distribution and the average of the means is different. That is because we made an assumption of how the individual data points are distributed in each class. They are uniformly distributed for our assumption versus having a raw data. So raw data will always give you something that is slightly more precise than if you make an assumption. Again, if you have the raw data, calculating the average is very easy, but not all data comes in the raw form. Sometimes it comes in aggregate. So that's why there's a difference between 212.1 and 212.084. Now, what we could try to graph it, and to do that we're going to use the mean and the midpoint and the frequencies, and we can create highlight those two, and we're going to go insert and then chart and then bar chart. Oh, that's the wrong one. Let's see if we can fix it. I'm going to skip a little bit ahead to the point where we actually get to see what we want. And so if we skip ahead, here it is. We have a scatter plot and we pick a bar chart or column chart. Bam. Now there is an option for histogram, but for some reason the histogram is making already its own assumptions versus just graphing what we want. So this bar chart is as close as we can get without tinkering with it. Again, you're more than welcome to, but that's not always necessary. So having that set up, we are going to look what we can do with the next step. And the next step is we're going to take a look at what we can do with the remaining values. So what we're going to do is we're going to highlight all the spreadsheet, and we're going to duplicate it into a second sheet, and we're going to call it sleep. After we have duplicated it, we're going to start looking into adjusting certain things. The first thing we're going to notice is that the class width has an issue, and the reason class width has an issue that on our raw data the class width is rounded down to 0.7, even though it's 0.744. So what we need to do is we need to figure out a way to round it up to the nearest decimal place. The way we do it is we multiply the class width we calculated in our old datasheet by 10, then we're going to round it up to 8, and then we're going to divide it by 10 to bring it down. That, of course, is much easier done by hand than in a spreadsheet, but nonetheless it allows us to do it. Now the rest of the data just needs to be adjusted for a different column, and again, after doing that, we have a second spreadsheet that produces some data.